So what we're going to do, sorry, move my cat out of the way.
Does your cat consent to be recorded?
She's not saying no, so it's probably fine.
Oh, the cat, okay.
Right. So for selecting block producers, what we want to do here is put in, this constant, the maximum number of block producers that we want. And for now, we're saying this number is like 100. How many blocks we want to have in the epoch, and this other constant, the limit on the probability that the smallest validator isn't selected. And then just the list of validator proposals that we have. And what we're going to get back is the chosen set of block producers, and also a data structure for sampling from them in O1 time complexity. So the way this works is first we sort the validators. And the reason we want to do this is so that we can always compute this S min over S really easily, right? Because if it's sorted, then as you go down the list, you're always going to be looking at the smallest one in the potential selected candidates. We just keep a running total for the total sum of stakes so that we have that at every step of the iteration as well. Right, so we're keeping track of the total. And basically we're just checking our condition that this stake isn't such a small fraction of the total that it would probably never be selected. And I have a little note here about floating point, and maybe this is going to be some non-determinism depending on the architecture, but that's sort of a minor detail.
Well, we should not use float, just saying that.
Yeah, that is sort of what I was getting at, is whether or not that's a concern.
Yeah, maybe we need some like Taylor expansion there.
That should be doable.
Yeah, and I don't think this needs to be super precise either, right? Marcelo also pointed out that this is just a heuristic anyways. This isn't like an exact computation of the probability. So yeah, Taylor series, and if we use rational numbers instead of floats, we should probably make that work. But conceptually, this is what we want to compute. So we're stopping when either the stake is too small or we've hit the maximum number of validators that we want. And then we just take advantage of the convenient built-in thing in the RAND crate, which I linked to here, to make the...
Also, I want to point out that this formula, everything in it is sort of constant. So I think we can solve for the ratio of the stake to total stake and just hard code the ratio, which still gives the probability that is acceptable. Because epoch length is constant, probability never selected is constant, right?
Yeah, this whole stuff is constant.
One is sort of constant, so
yep.
Yeah, we can just solve it for the ratio, find the acceptable ratio, and just take it while it's not too little.
Yep. Also good optimization, because then we're not doing this calculation over and over again. I like it. Yeah, now we're done with this. So the way we use this then is at height h, when we want to select a block producer. Essentially, we just put in a seed that's fixed for the whole epoch, and then hash it against the height to generate a seed specific to this height, and then create a random number generator based on this seed and sample from our O1 sampling data structure and return that. Does anyone have any questions or concerns about this other than what we've already mentioned?
So something to emphasize here is that we're completely removing the concept of the validator seed, right? And so now we just have block producers, and we just sample from the block producers instead of having validator seeds which have equal stake and just uniformly sampling a seed. We have block producers which have different stakes and just sampling weighted one block producer.
Yep, that's exactly right.
One thing is that we need the random number generator to be easily reproducible in other languages and should not be specific to like Rust implementation, because it defines a protocol. Like we probably should not use something that's specific to Rust that defines a protocol, and also probably should not use something that uses float ideally, because that gets messy.
Yeah, so the Cha-Cha random number generator here is based on this paper. As far as I know, there are more than one implementation. Like obviously there's the Rust implementation, but I think there's a few different ones. We can look into that more though. But yeah, that's definitely a good point. Is that we want it to be reproducible in other languages and to be well defined. And that's also true of this data structure, this weighted index data structure.
Yes.
This is like based on this alias method, which they don't link to here, but there is a paper that describes it, and it's also in the Art of Computer Programming, as someone in the GitHub pointed out. But yeah, so I think all the algorithms are going to be well enough known and not just be Rust specific things. But yeah, that's a good point.
And before we proceed to the chunk production, I think the primary reason why we actually had validator seeds to begin with and didn't implement it by weighted sampling before was that we wanted to have the samples that are assigned to the shards to have approximately the same stake. And I think at this point, this requirement is removed because we do not rely in the shard security does not rely on the stake assigned to it, right? So that's why we can remove it.
Yeah. So yeah, let's move on to the chunk production and talk about that. So Alex, so originally what I was trying to do is just assign roughly equal stakes to every shard. But as Alex is pointing out, maybe we don't need to do that. And so he points out an example where, this very simplistic way of doing the assignment does, not a great job because it gives one validator to the first shard and 4 validators to the other shard. So maybe the condition we actually want is based on the number of validators that ends up assigned to each shard. And
I think there should be a lower limit on like number of validators assigned to the shard. Like ideally, there should not be like a shard with one single chunk producer, and that would cause problems.
But what I'm suggesting that we should just assign equal number of block producers and completely disregard the stake. We do not slash for being offline anyway, so it doesn't really give us anything.
Yeah, I think we talked about this before, right? There seems to be an argument saying that some shards will be less secure than others.
But they're going to be less live than others. Why? But security of the shard does not depend on the stake assigned to it.
It depends in the sense that when you slash them, like it's like the amount of.
You're saying economic security of the shard.
Yeah.
I see. Yeah, okay, that's a good argument. So probably we need to balance between the stake and the number of block producers assigned. So yeah, I guess that's not that easy. So we want to assign based on stake, but then we want to ensure that there's some minimum number of block producers assigned to each shard.
And then Marcelo also pointed out that if we have more shards than validators, then we also need to actually dip into this validator pool more than once, right?
I think the assumption is that will never happen.
Okay.
I think it's fair to assume that.
So we'll add that to our list of assumptions, is that there are always fewer shards.
Well, yeah, so I think it's fair to assume that would never happen in like production. Maybe in testing we can have that, but yeah. But I think it's fair to assume in production it would not happen.
However, in our testing, indeed, we have a lot of scenarios where we do want to have multiple block producers per shard. So yes. I think it's better to design having it in mind.
Yeah, it should not crash like if that happens. Like, but like we probably don't need to put a lot of thought into making that work like very well.
So one thing we could try to do is change this loop so that we're right. So we're just going to cycle over the same validator set over and over again, just to cover the case where there's actually more shards than block producers. And then the exit condition on this loop is now going to be um, want to say basically if the minimum condition has been met, right? Like the minimum number of block producers condition has been met.
Yeah, actually, it seems like, well, I didn't like check very closely, but it seems like it's similar to what we have today in how like we divide block producers into chunks. You can look at like, I mean, yeah, it's like looks similar to me. Like you just like cycle through and then, yeah, I think we already have something in our code like this.
Like completely naively, if we just add the exit condition here right now, we will end up in a situation where the same shard can be assigned to the same block producer multiple times. So it's like imagine number of block producers is 4, and number of shards is 4, and they have equal stake, right? You will continuously add the same shards to the same block producers.
Right. Yeah. So yeah, that's a good point.
Yeah, something more sophisticated will need to happen here. But I think the actual production case we're expecting, right, is something on the order of like 100 block producers and 8 shards. So this loop will just assign 11 or 12, whatever it is, block producers per shard and will exit. So that will just work. Again, it depends on what is going to be the stake distribution. I think if we take 100 people, the top one, like hypothetical Bison trails with all the delegates will be way higher than number 100, whomever it is.
Yeah, presumably it'll be like an exponential distribution, right?
I think in my current implementation, I just guarantee that at least each shard has one validator, if the number of shards is larger than number of validators. So I just implement it so that it doesn't crash, but it's for sure probably not an optimal way to do it. But I just don't think we need to make that optimal as well. So
we need to make sure that there's at least like 5 or like block producers per shard to provide some liveness.
Well, but I mean, realistically, it wouldn't really happen in practice, right? Like having more shards.
In practice, we will have, as I said, Bison trails having like 20% of all the stake delegated to them, right? And then there's going to be someone at position number 100. So like Bison trails will.
I see.
Yeah, like Bison trails will grab one shard and nobody else will ever be assigned to the shard, hypothetically.
I see what you mean. Yes. Okay, yeah, I guess what. Yeah.
Hey, I'm just driving by here. I have not read it, but one thing I want to mention is like in the future, we'll want to be able to like as an option to allow people to rent some capacity, which is the easiest way is to just give them a shard with some limited gas limit, for example, and then we can bundle multiple of the shards into the same block producer, into the same chunk producers. What do you guys think of this?
I mean, like give them like part of the address space, or how do you want to give them a shard?
Yeah, let's say I'm like I have I'm as a company or whatever, I can, or a decentralized protocol, I will pretty much lock someone of near for this set of contracts or this set of accounts to live in a separate shard and have separate gas limit.
Yep.
And yeah, I mean the reason is like oracles have the need in this, because otherwise if they start competing with others, they may they may not provide the price.
I think go ahead, Bowen.
It seems that's hard to do because, well, depending on how many accounts you want to lock in, because then the mapping between address space to shard would be non-trivial, and you need to you need a fast way to compute that.
Well, if that, like you can special case those shards. Like your lookup will say, is this account one of the paid accounts? If not, then.
But if there are too many of those accounts, it becomes a problem.
Well, make it sufficiently expensive so that there's never too many.
Yeah, I mean it's some amount of near is pretty much like burned or locked in this operation to justify everybody knowing about this.
But that should be relatively orthogonal to the block producer selection, right? So like from perspective of the assignment, that is just a shard, right? It says, well, I have 10 shards of those 2 are paid or whatnot, but
Well,
it's just 10 shards, you know?
Well, yeah, so the point more is like we may want to bundle some shards into the same chunk producers. Like if let's say this shard is only like 2 teragas.
Oh, I see. You're saying
And
some
there's
shards.
like five of them. Yeah, some shards are like less.
Oh, so shards have weight now, which says how. I see.
I mean, if this algorithms were like too simple for you guys, I don't know. Not gold medal level, is just adding a little bit more.
But is that some sort of like resharding in a way, like you sort of like bundle shards? That's like.
I mean, we don't need to like do it now, but it would be nice to have that like easily addable versus need to refactor everything again.
Yeah, I think the only thing that will get refactored is this actual loop, which we're looking at right now, which will have just to assign fewer block producers to some particular shards. Yeah. Like the only thing you will actually have to change is the assignment of shards to block producers. Which should
be chunk producers, yeah.
Yeah. Chunk producer and block producers are synonyms.
Okay, so I guess for the sake of wrapping this discussion, the main thing that we want to say is we need to support the case where more shards.
Right.
But we want to optimize for
Yep.
And we want minimum number of producers per shard.
Yeah, while still trying to balance.
Yeah. Okay. So maybe I'll just take this offline and I'll try to rearrange this loop and make it meet all these criteria. And I guess I'll ping in the GitHub issue when people can review it again.
Cool. Okay, so we have one last section left.
Yeah. So then, assuming we can do this somehow, right? We can create this list of assignments. Then the way we want to assign block producers to chunks at a given height and a given shard. Alex had brought up this idea that if we can set it up so that the block producer at h+1 is the chunk producer at h, then this sort of reduces the amount of network traffic you need to send chunks around because the chunk will already be present when it's time to make the block. So this if statement is purposely trying to make that happen, right? So we check the block producer at the next height, and if they are assigned to whatever shard we're interested in, then we assign them to make the chunk. Otherwise, we just loop over the assigned candidates. And so Alex pointed out that if we do this and we have multiple shards per block producer, you end up in a case where at a given height, one block producer might have to make multiple chunks. And the question is whether or not we're okay with that.
Which I think we are. So first of all, we sort of above stated that we don't really care about the situation, right? But moreover, I think the chunk production is pretty cheap, right? And so from this perspective, even if the block producer is assigned to multiple shards, the savings from not routing all those chunks before block production is way higher than whatever is the overhead of creating chunks. So we should just have the block producer produce chunks for all the shards they track if they are producing the next block. And the way this if statement is written will achieve precisely that.
Yeah, it seems to me that applying the chunk would be like more work than creating the chunk.
Yeah.
So like if
and
they are,
everybody has to apply, right?
Yeah. So like if they are able to apply those chunks in different shards, it seems like there's no problem for them to creating chunks in those shards.
Yeah. And so for the selection, in the case they are not block producers, do we want it to be weighted the same way we do it for block producers, or do we care at all? I think in this case, weighted hurts more than it doesn't, because if there's like 5 of them assigned to a shard or 10, and a major stakeholder goes offline, we sort of get pillaged.
Well, but like, does it actually matter, right? Because if the major stakeholder offline, he will miss the corresponding number of blocks. So like, it seems like the chunks would not be included like anyway in that block.
But they have lower percentage of blocks than chunks.
Oh, I see. You're talking about per shard. Oh, okay. I see. Yeah, I think that makes sense.
Yeah, I think using as written right now is probably fine.
All right. Cool. Any other
questions?
comments or questions?
I mean, not like just want to elaborate on something we talked about before. I think we should actually look into the random, like the algorithm related to the random numbers, because I suspect that might not be as easy as we think. Like, and just make sure that it's actually possible to, it's not too hard to replicate in like other languages and so on. And it doesn't depend on float. I do like if it does. I think that's probably harder thing.
Can we just go ahead?
Yeah. So we should just like do whatever's the simplest, stupidest thing is possible, because we already have randomness. Like the randomness beacon gives us the randomness, so we just need like a way to draw numbers from that randomness.
Yeah, I think we should just concatenate the epoch random number from the beacon and the hash SHA-256 and get whatever the remainder is.
Oh, let's use this linear feedback shift register, which is
or SHA-256.
Okay.
But SHA-256 doesn't give you a number. You need a number.
Well, Alexei modulus
most certainly gives you a number.
I mean, yeah, this number is just large.
What about next number?
What do you mean? We need one.
We need multiple.
In this particular use case, we need one number.
Do we?
Yeah, we need one number for the height and the. But if you need multiple numbers, then the ordinal of the number you need, you concatenate it to the input and SHA-256. Or if you feel adventurous, you keep on SHA-256 in the same.
Proof of history?
Yeah, you do Solana style.
Okay, I can make a note of that as well. So.
I see. So actually, at every step, we only need to generate one number. There's never a case where we actually use the seed multiple times. I see. I think makes sense.
No, the seed is epoch seed.
Yeah, but like you always like create a new. You always create a new seed for every height. Like you don't actually use the epoch seed to like run the random number generator multiple times.
Well, depends on what you mean, right? We use the same epoch seed, but different heights. And so when we concatenate, the pre-image of the SHA-256 will be different, yes.
Yeah, that's what I mean.
It's fine. Yeah. Point is the call to block producer sampler.sample is 1.
Yes.
Per the
okay,
RNG,
that makes sense.
Per 1 RNG. So yeah, so let's kill the seedable RNG and replace the sample operation.
Then you don't need seedable RNG, like because you
SHA block seed mod whatever the block producer lengths.
Yep.
And that removes like a very shitty dependency that we have right now.
Oh wait, we're using Rust random number generator today?
Yes, it defines the protocol.
There's no way to reproduce this at all.
Yeah.
Oh, that's incredible.
Yeah, it is incredible.
Yeah, it's quite bad. I'll look into the details of this. Like, we still want to call this sample function. Like, we can't just uniformly take it mod the length and then just use that as the index, right? Because the point is we're still doing a weighted sampling.
But given the sampler is in Corman book, I think we should be able to implement it ourselves in the reproducible manner.
Yeah, I
It
mean,
was not intended as a joke, but I'm happy you liked it.
It's certainly doable. It's non-trivial, but it's doable. Okay, sure. So yeah, I'll just make a note.
Cool. Shall we switch to the nonces? So in this particular case, we can just like rewrite seedable RNG from seed, replace it with SHA-256, and that all just works. Yeah. Anyway, yeah, Eugene is here, but I don't know if his sound works. Eugene?
Test.
Oh yeah, that works.
Okay. It works well.
Cool.
Well,
I don't have anything to present.
Shall we do the whiteboard?
We can try the whiteboard.
No, not the Zoom whiteboard. I'll send the link.
Okay, send the link.
It's in the chat.
Okay.
It's Marcelo's recommendation.
Oh. Okay. I can present.
Please do.
That's not advanced enough. Brave browser. 1 second.
It doesn't work in Brave.
No, it doesn't allow to present tabs.
You don't want to share the rest of your tabs with us?
Yeah. Okay. So the idea is right now we use nonce on every access key. And nonce is a number. It's, for example, starts with 0, but it doesn't have to be. So every access key on the account, let's call it AK1. Well, I guess I can type AK1, 2, 3. So there's different access keys, and every nonce right now is used when we determine whether a given transaction that signed with the public key associated with the access key unique or not. So let's call it public key 1, public key 2, 3, and
also,
nonces.
to clarify, does it actually affect the log drop? My understanding is that in the log drop, every drop is a unique access key, right?
Link drop?
No, but it's sent. The sender is the same, right? Like
But the access key is different.
Yes, access keys are different, and public keys are different.
Okay, so it doesn't affect log drop per se, but we still should fix it.
No, but isn't the create isn't when you're creating
matter.
it, you create from the same access key? Like when that
But
syncs.
you can create an order. You can create in advance, moreover. When they claimed, that happens in different access keys.
Yes, that's true. Yes.
What's the issue trying to?
Oh, so Bowen was saying that log drop is affected by the consecutive.
Like you cannot drop like more than 1 per second.
Log drop?
Like if you drop from link drop. If you drop from one, if you drop from one account, you're sort of limited by the account. Well, I assume. Well, I mean, we don't have to discuss it here.
You can drop from multiple access keys.
Yeah.
Yeah, just like you need to drop from like multiple access keys.
Yep.
And then some like
I don't know. It doesn't really affect it as much. You can call it from multiple accounts. Like
yeah,
if you
then
wanna
with the thing we need to create multiple accounts, and then users will not have .near suffix, but I guess it's all fine.
Okay, maybe. All right. So currently nonce is a number. It can only increase, but it doesn't have to be increased by once or by one. So let's say we have a transaction at a given access key. So let's say it uses nonce 4. And what? And another transaction is using the same access key, but it uses nonce 5. When they arrive to the pool, when they pulled from the transaction pool, we sort transaction by access key and account ID and by nonce as an order. So we group them by access key and account ID, and then sort them by nonce. And we first pull the transaction with the lowest nonce, and so on until we and we rotate it properly. So the challenge here is if you first send a transaction 4 and then transaction 5, and let's say you hit different RPC endpoints, then transaction 5 can be forwarded first, but transaction 4 might not be forwarded on time, and transaction 5 will be accepted, which will make transaction 4 invalid. So nonce is going to be updated to 5, while transaction 4 would be effectively skipped. And since this becomes invalid in the middle, it was just dropped from the pool. We don't report the error properly, so it leads to the bad UX. Because now we need to figure out why it was rejected on the client and stuff like this, and why it doesn't know the answer and stuff like this. So,
and so my understanding
here,
that, so nonces, they solve two different problems, right? So one problem is that we don't want to apply the same transaction twice, but it is hypothetically possible that you do want to play the same transaction twice, which is the same in every aspect except for the nonce, right? So we need to distinguish, like imagine I want to send you five news twice. We need to distinguish between seeing the same transaction twice or seeing two different transactions, right? But the second thing that nonce is solving, is that it could be that I sent a transaction and for some reason it got stuck, right? Like I didn't attach enough gas or whatever, or like it is not happening, right? So I want to, it could be that I want to make sure the transaction doesn't happen anymore, right? So like I want to cancel it before sending a different transaction, which includes the effect of this one. So in this case, I'm sending another transaction with higher nonce, wait until that transaction lands, then I know that the previous transaction doesn't happen, right? So effectively, it's a way to ensure that certain transaction doesn't happen if it gets stuck for some random reason, right?
Well, I would generalize.
Kinda.
I would generalize the second one as it allows you to create dependencies between transactions. Whether you are solving the problem of like transaction getting stuck, or whether you have a like complex D app which spits out a bunch of transactions, but you want them to be executed only in a given sequence.
But the dependencies don't work, right? Because the previous transactions can get skipped.
Well, I mean, it can be like a partial dependency. It's like, I don't want this transaction to be executed before this other one.
Right,
so,
but
and the third one is we want to replay protection. The same transaction should not be applied twice. And
by replay protection, you mean on other forks, or what is it?
No. So let's say you have a transaction and like 7 days later you have the same transaction. Yeah. So you need to like figure out why it doesn't work anymore.
But that's the same as unique transaction, no?
Well, it's somewhat similar. So yeah, so they kind of okay. How I move?
You need to choose the hand on the right. Yeah.
I see. I see. Okay, whatever. Yeah. So it's kind of the same, but serves two purposes. So we first of all want to accept the transaction, for example, transfer from Alex to Max, then near, and then again the same transaction, Alex to Max, then near, if it's a different transaction, but everything inside is the same. So right now, nonce somewhat solves these two problems. It allows you to order transactions, and it also allows, so ordering creates kind of dependencies, and it also allows you to have replay protection, because if you have a transaction with nonce 4 or 5 and current nonce is 5, they both became invalid, so you cannot replay them. And it gives you uniqueness because hash is different. If you send a transaction with nonce 4 again, then it will be the same. But if you send exact content but the different nonce, it can be a new transaction. So the proposed solution, okay, so this is like the problems we're trying to address. It also has issues. So issues are the following. We can skip transaction. We can't send, like we need to manage nonce on the client. So we can send more than one per block. And how I close chat. And the second one is challenging because if one of them is not accepted, then it's going to get skipped. Like if it was not routed on time to the validator, then it may be skipped. So the proposed solution was if we replace nonce to be unique, for example, SHA-256, unique bytes. So what we do is we need to address two problems: how we solve replay protection if now we don't have a nonce on the access key. So no nonce access key. And so to solve, so transaction is unique. We need to solve a replay protection, and we need to solve dependencies. So replay protection can be addressed if we remember that transaction has expiration. So expiration, and we basically just need to remember all transactions before expiration cutoff. So if expiration window is limited, then it's possible to store them in a state somewhere or in the cache. So when nodes, when nodes sync up the state, then it will have to pull all this from the past blocks. Or
well, I mean, that doesn't work naively, because it could be that it now tracks some shard it doesn't track before.
well,
If it's part of the state, you naturally have the state of the shard.
Well, yeah, but Eugene is saying that you don't put it in the state. That
Well, yeah,
makes things more
Yeah, we cannot
I
put it
see.
in the state because, I mean, if you put something in a state, you need to define the limits. And as soon as you define the limits, you need to figure out how this stuff is not abusable. Like, how do we prevent some validator from putting 100 million transactions in the state and claiming that that's what they received in the transaction pool?
No, well, that's gonna be like miracleized. So no, this is only accepted transactions that were accepted in a block. So we don't care about new transactions that were not accepted. So it's only a transaction that were included in the block, and only hashes of them actually. Like we don't care about actual.
I think we can discuss this later, but it seems I think there's some problem there.
Okay. Well, first of all, they need to have a timestamp or like structured in such a way that they can be cleaned up efficiently as well. So you produce a block, you know that this transaction has to expire after this height or something. So it can be like garbage collected properly. And dependencies, when we originally discussed dependencies with Max a long time ago, we wanted to have direct dependency. You say my tx depends on txt. So idea here is you specify a hash of the transaction on which you depend. And if hash is not there, then your transaction cannot be accepted. And it can be nonce or it can be none. In this case, it's accepted without dependency problems. And that way you can order transaction in any way you want without having to know the nonce. But for this, mempool has to be more complicated.
Wait, where is the dependency? It seems that this implies lack of dependency, right? Maybe I missed something.
The transaction can include the hash of the transaction depends on.
Yeah, it's a new
field.
field.
Okay.
Field to indicate parent.
The dependencies can be built later separately, right?
Right.
So
yeah, dependencies are not required.
Yeah, that becomes feasible. So does it have to be SHA-256s? Can it just so effectively the question is can we just still use nonces? But instead of having a number, have like a bit mask which says those nonces did execute and those did not yet.
Yeah, because
you mean like a Bloom filter?
It's not even a Bloom filter. So the way I see it, it's exactly the same approach as you suggest, right? So nowhere here we actually rely on that blob to be a large blob or a hash or anything, right? It just needs to be unique per transaction, right? So you can use the same nonce which is stored on the access key, and then you can have this. So let's for now assume that the transaction validity period is constant across all the transactions, right?
Sure.
It doesn't have to be the case, but it's going to simplify the idea. Then instead of having a hash map where you say, well, for this hash as I saw, you have a vector, or rather like a DQ, which is indexed by the nonce, right? And so you know like you're pulling out the oldest nonces, you push the newest nonces. But you can still, on the client, for example, it's still enough for you to just know the latest nonce and you can submit with increasing nonces, right? It has a problem though, if you have multiple clients, you can accidentally send transactions with multiple nonces. This is also the problem we have today, which does not exist with the random hash.
Well, I mean, the problem with like using SHA-256 is that I think I did calculation. You need to store like up to 1 GB of data in state. That's very suboptimal.
For access key or for everybody?
For hash, like for hash of transactions.
For everybody.
Yeah, for everybody. Yeah.
Basically,
Well, I mean, that seems
Per
about
shard, yeah. Per
Where
shard,
is
you mean?
where
Per
is 1
shard.
gigabyte coming from?
86,000 times 500 times 32.
Where is 86,000 coming from?
Transaction
Seconds.
validity period.
Why we are not storing transactions in a state?
We're storing
No, we're storing the hash.
hashes of executed transactions in the state.
Hashes of the executed transactions in the state. Why are we storing them in a state? We're not storing them in a state.
So that you can prevent
Yeah,
replaying them.
I mean, that's a proposal. I mean, I'm not talking about what we do today. I'm talking about the proposal.
Wait, we already have preplay prevention today.
Yeah, but
Using
I'm
nonces,
talking.
we're suggesting to remove nonces.
What is the motivation? Like, what are problem trying to solve here? Before
Where were you for the last 25 minutes?
I was here. I
So
still did not understand the problem.
So 2 problems. We can skip transactions because RPC routing is not consecutive.
Mm-hmm.
So you send a transaction to, for example, load balancer, not in a batch, or like from 2 clients, and a transaction can be skipped if it's not received on time.
But so none of our clients actually came to us and said that it was like a problem.
No, Stardust came there. I complained about this a lot.
I heard this complaint many times over the time.
So you cannot just like, let's say you're trying to issue 5 transactions per second. That's pretty much impossible to get all of them accepted. So no matter how hard you try, like some of them gonna be lost.
So like nonsense is like a very common concept in a blockchain that people are familiar with, right? And if we deviate from it, I mean, some other people gonna get that.
So nonce comes from UTXO, where this problem doesn't really exist.
Even in the Ethereum, if you look at the design decisions document they have on GitHub, where they sort of try to rationalize all these things, they actually say explicitly that the nonce was put there because they needed to solve these problems and didn't have some great ideas, but they have a little footnote that says, we don't like this and we want to do it better. So
okay, I see. Cool, thanks.
Transactions do get dropped. People do report drop transactions.
Yeah, I mean, people get annoyed at us because of that.
But it's also like client-side implementation is kind of terrible. So we need to adjust like nearly if there was issue for a long time, but it still doesn't solve the issue where you're trying to, like when you actually have routing problems, like it will happen.
But separately, Bowen, I think 1 gigabyte per shard is acceptable, no?
Is it? I'm not sure. Like, yeah, we can discuss.
But it's Bowen, you assume full load, like every single block.
Well, yeah. I mean, of course, you should assume that you should consider the worst possible scenario.
Yeah.
What is
then
500? What
one,
is 500? 500 transactions per second?
Per block, yeah.
Oh, that's pretty optimistic.
Look.
No, that's a limit under current circumstances, I think, under current configuration. Yeah.
Like all clients need to do the replay of the RPC requests anyway.
Well, the idea is that the transactions could have been received by 2 different clients, and then at that point, there is no guarantee that they will reach the actual chunk producer in the same order. They can receive the chunk producer in reverse order.
Yeah. I mean, that is a problem. So it's not that the transaction get lost; it's that they receive in different order, and because of that, some transaction get invalidated.
Okay.
It also will simplify our mempool, probably.
Right now, the problem is that we accept not the sequence nonces. So I mean that in Ethereum, for example, node accepts in the queue, they accept only potential nonces. We accept nonce. Our validation here is that we accept nonce which is greater than previous one.
So let's say we have nonce strict has to be +1. So for this, the issue was
multiple clients.
You need to like, you need to wait. Yeah, you need to. Well, multiple clients in theory should not share the same access key. So it was not like a huge issue, but it happens like occasionally. For example, when you drop an access key as part of the link, and people will be able to use it without like having to log in with their account. So use case might exist where multiple devices try to access the same access key. So you need to wait for all previous transactions.
Well, you can just optimistically send the transaction with the next nodes. They will eventually.
So the pool growth, the pool needs to maintain delayed transactions. Right now, it's not an issue, so pool getting drained, so you cannot attack the pool.
But even if the pool drops a delayed transaction, that's fine. You can always resubmit it, right? That can be solved on the client side.
It means you drop the transaction, the other transaction. So, like, let's say you're trying to send 10 transactions per block. That's gonna be pretty challenging because let's say the transaction number 3 is dropped. Now you need to send 3 and all declined transactions plus 10 more. So now you have chance of dropping is even higher. So you will eventually lose the TPS.
So one problem I have with the solution 1 and dependencies is that the point of the dependencies is, well, to create dependencies between transactions, right, that modify the state of the account. But the state is shared between access keys. So it's kind of weird to have both nonces or like whatever dependencies per access key and the dependencies like you described in solution 1, right? It sounds to me like we need to, if we have dependencies between the hashes.
Like not optional, basically. It's not part of the of this discussion for now. So we're only trying to address these two problems. So we say there's no dependencies on access keys, but you can always implement them within your account or like within a contract if you want to. Maybe you cannot do this on the client side.
But it feels to me that the problem in the solution 2, where the pool keeps delayed transaction, in solution 1, is that the delayed transaction will happen, right? But it will skip all the previous transactions. So this is no more desirable than dropping it.
Well, yeah, sure. The second solution is like or drop them.
So effectively, I think like there's one use case that I can envision in which I just want to submit 100 transactions and I don't care in which order they happen, right? So it obviously still works with consecutive nonces. It doesn't. So it works.
Well, it doesn't work if we.
Yeah, it doesn't work if if the transaction with smallest nonces somehow dropped. Like it doesn't get through.
Yeah, it's like delayed later, like routed later. Everything that you sent before has to be resent again.
Yeah, I think it's suboptimal.
But we should just like if we have in the pool transactions with multiple nonces, we should always drop the highest nonce transaction, which effectively means if I drop the transaction with the lowest nonce, that means unless I didn't receive them yet.
Yeah, I'm talking about the case where it's actually dropped, not dropping the pool, but the transaction didn't arrive for some reason.
Transaction didn't arrive.
Yeah, so we're out of time. When the new transaction arrives, like second one, before the first one accepted, it will be dropped, but it might be routed to a different validator. And your first one, or like this validator will not know about this transaction. So that will create a ton of issues.
Yeah, exactly. Yeah, that's probably.
So strict nonce doesn't work because we cannot guarantee that the same validator will have all transactions.
Yeah. So it feels to me that strict nonce is still strictly better than, one second. Yeah,
No,
it seems to me
it
that it's
means-
still better because in the, so let's say I want to send 100 transactions and I don't care in which order. In a strict nonce, they,
The first one will get accepted.
but
For
like,
sure.
so let's say I have a layer in front of me which just retries transactions, right? Then all my
Right.
100 transactions will happen. While in the case of, well, I guess in the case of non-consecutive nonces, that layer can be smart enough to resend with different nonces.
Yeah.
The beauty of the first one is that the first one doesn't need to know the state of the system. It can be like a very thin layer.
Yes.
It sends transactions over and over again, while the later does need to have more insight into.
Well,
yeah. Anyway.
Solution one addresses both of them because we will actually can get 200 TPS from multiple clients, from one client, but it needs to implement this particular problem. And we will clean up nonce from access keys, which is also a good idea.
But if Bowen, if it is not a SHA-256 but an 8-byte nonce.
Yeah, I think that's slightly. Yeah, I think then it's like 250 megabytes, which is still larger than what the size of state that we have on testnet today. But I mean, and that's a single shard. Well, I don't know. Like, I'm not sure whether that's like okay or not.
I don't know. On testnet, we have Sasha services. There's Dustin's contact from LinkedIn straight into the state.
You know, this meeting is recorded and will be published, right?
Yes. Well, it's public information.
Well, yeah, I mean, if we think that's okay, it sounds like a reasonable solution to me. I mean, 8 bytes should not have collisions, right? If you just 8, yeah, it should be like.
So basically, what we say.
By one, and you have more than 1 transactions per second, you will actually get relatively quickly. So 1 transaction per second with increasing by 1 billion gives you 30 years or something like that.
Well, you can use microseconds. And
oh wait, 8 bytes. 8 bytes is not 4 bytes. Yeah, 8 bytes will be enough for the lifetime.
But you can rotate them. You can.
8 bytes you don't need to rotate. You will not get 8 bytes by one.
Yeah, 8 bytes is pretty large.
Okay, we're out of time, so let's discuss this later on.
Yeah,
it's currently not a short-term thing that we're gonna go for because it's not breaking our UX as much. Just make it slightly suboptimal.
Okay, thanks everyone for participation. See you next time.
Thanks.